All right, moving along. Here we go. Problem 8 asks me to make things perpendicular. So by this point, it should feel pretty familiar. We're going to dot product and make it equal 0. So we're going to dot product. So we'll have turn on the pen. There we go. A dot B is going to be 2 to the x times 2 to the x plus 0.5 to the x times 4 to the x minus 4 times 5, and that's got to equal 0 because they want it to be perpendicular. So 0 is going to equal 2 to the x squared plus 0.5 to the x times 2 to the x, or times 4 to the x. I'm second guessing myself here. Why am I second guessing myself? Does that come out to be 2 to the x? 0.5 to the x times, yeah, you can do that. Crazy. Okay, I was second guessing myself there. Minus 20, and that can be factored to be 2 to the x plus 5 times 2 to the x minus 4. This will never equal 0 here. Can't equal 0. 2 to the x can never equal negative 5. But this one, 2 to the x, can equal 4, and that occurs when x is equal to 2. So it appears that when x equals 2, the two vectors are perpendicular. And so vector A would equal 4, 16, and 5. Vector B would equal 4, 1/4, and negative 4. And you should just double check that that actually makes 0 when you dot product them. The first coordinates make 16, the second coordinates make 4, and the third coordinates make negative 20, so that sounds good to me. Okay, part B. Find the equation of the plane that is given by the vectors in part A and passes through the point 1, 1, negative 2. So then we are going to now take the cross product of A and B. And so we just do our 3 by 3 matrix and we find the determinant of it. By now this should feel pretty familiar. So we're going to go I times negative 4 minus 5/4. Okay, minus j times negative 16 minus 20, plus k times 1 minus 64. Okay, we're almost there. So that's going to, here, move this out of the way. That's going to leave us with the column vector negative 5.25. I guess I'll just do decimals. And this is going to be positive 36, and this is going to be negative 63. So that vector is normal to both A and B. So if we dot product that with the given point P, we have the equation of the plane, and it will equal 0 because the normal vector is perpendicular to every vector inside of the plane. Okay, so what do we got? Negative 5.25 times x minus 1 plus 36 times y minus 1 minus 63 times z plus 2 needs to all equal 0. There's no need to distribute it out because it just asks for the equation of the plane, so we did it that way. I guess actually at this point I should mention it didn't specify what version of the plane equation that you had, and so you could have written your vector version of the plane and said, oh, check it out, the plane goes through these points 1, 1, negative 2, and it has one parameter mu times the first vector and another parameter, not mu again, another parameter, lambda, times the second vector. And that was probably an easier way to do it because then you don't have to do the cross product again. But if you watched this far in the video, you just got to see one more example of me taking you through how to do a cross product. So you are welcome. Thanks for watching.